Welcome back, where we turn questions into answers. So today we're going to focus on a little bit of algebra. We're going to touch on some exponential laws, work through some of our inequalities, and maybe also some of our nature of roots. So it is only 4 questions we're working through, and then we will review and see some key aspects in the questions. Please allow yourself to dive into each of the sections respectively if something starts to feel amiss. First and foremost, obviously we're going to solve for x. Alright, so that's the first one we're doing. We're going to solve for x. Okay, so we're going to start off. Our question is, you can write it out with me, x bracket 2x minus 3 close bracket equals 0. So very important, when we're solving for x, we understand that in most cases we will get one specific answer. So if we had, for an example, x plus 2 equals 0, we'll understand that x will equal negative 2, because whatever we do on the left hand side, which is so there was a plus 2, so we basically added a minus 2. And on the right hand side there was a 0, so we then again going to add the minus 2. So what I'm just bringing into remembrance again is that everything we do on the left hand side, we added that minus 2 on the left hand side, we're going to add a minus 2 as well on the right hand side. All right, so we did the minus 2, so we can then say plus 2 minus 2, so that we lose the number value on the left hand side, and we then, in maths lingo, move it over to the right hand side, but that's basically where it comes from. Additionally, we know, or we must keep in mind in B, that when we move over maths lingo, an addition to the other side, it will become a negative, or a division to the other side will become a multiplication, and the same vice versa. So as long as you have that in remembrance for solve for x, let's dive into it. Also remembering that we must always note how many terms we have in our question. So as you can see in this question, we only have one term because it is separated by a multiplication. And we know that multiplication makes 2 different terms, or 2 very varying numbers, maybe that's the way to put it, into one term. It all looks very similar. So all we basically have to then do is x equals 0 or 2x minus 3 equals 0. All right. Then you must just keep note, or keep just be vigilant of the fact that we are not done on the one side. So then in this case, we're going to add a minus 3 on this side to get rid of. And so on the right hand side, it will be plus 3. So let's just rewrite it. 2x minus 3. We're going to plus 3 equals 0. We're going to plus 3 on the right hand side. Everything we do on the left hand side, we do on the right hand side. So then we have 2x equals 3. Everything we do on the left hand side, we divide by 2. We're going to divide by 2. Therefore, our final answer would then be x equals 3 over 2. These being our final answers. 2 marks in. Very nice and easy. The next question we're going to do, still underneath the solving for x. I'm just going to rewrite it. And then you can pause and try to attempt it first. So we have 0 equals, let's do 3x squared minus 5x minus 11. All right, you're more than welcome to pause and give it a try. All right, so we know solving for x, we could definitely use simplification. So let's start there. Simplify. And to simplify, we would factorize. So 4 possibilities to factorize. 4 for factorization. Highest common factor, difference of 2 squares, trinomials, or grouping. So we know that our solving for x, we supposed to, or easily be able to just take numbers and maths lingo, move them over the equal sign. However, we see that we have three different degrees of x. We have x squared, x to the 1, and obviously x to the 0, which we know equals 1, and that's our number value that's attached to the 11. But we have three different degrees of x. So we definitely can't just move it over to the other side or take out a highest common factor, because our value of x isn't the same. Okay, so the degree, meaning not like the value, but the degree of x is not the same. So what we can then move into is to trinomials. So let's do that. So obviously we would want to just open it up into two brackets, putting the two terms when we multiply give us the first term, and the last term, I'm just going to put c, a constant and a constant. Those last two terms will give us our last term, and those two terms will give us our first term, and then obviously we'll have our middle term. However, you can see in this question that we do have a coefficient before our first variable. So here's our coefficient. So we can definitely use which other method? You must remember we have 3 minutes, 3 marks. We want to jump into it. And again, the variables of 3 and 11 will give you like 33, or will give you, definitely will not give you 5. So we're going to jump into it. So I'm hearing someone go x equals minus b squared plus minus square root of b minus 4ac. Okay, I just did a mistake there. I'll raise it now. Okay, so I just did a mistake there. So let's redo it. So it's x equals b plus minus square root of b squared minus 4ac all over 2a. So another way to remember it, so my mistake was that I squared the first b. So the first b is just negative, right? But the b squared, you must remember, comes in nature of roots. And in nature of roots, we know that we can never have a negative underneath a square root. So that's another way to always remember that b squared goes into the square root, and definitely not with the first b. However, the first b is negative. So just a reminder again, in case I did confuse you, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, and then obviously we then just substitute. Our a value is positive 3, our b value is negative 5, and our c value is negative 11. So if we put that in, we have x equals negative, my apologies. Our b is negative 5 plus minus square root of negative 5 squared minus 4 times 3 times negative 11 all over 2 bracket 3. All right. And then just remember to obviously put it in your calculator for the first example to be a positive, and then the second one to be a negative, where you're going to get an x value or another x value. All right, so you just have negative bracket, negative 5 plus minus bracket, negative 5 squared minus 4, 3 times that negative 11 all over 2 times 3. So you should get like 1,25 or 1,2.92. All right. Okay. Still with me? So we're still solving for x. Our question is still solving for x. But now we see 3 different examples. The first solve for x was a nice straightforward one. A few options of the value of x. X could either be 0, x could be 3 over 2. Another one is using or coming from understanding that simplification of the one side, either the left-hand side or the right-hand side, could require you to first take out a highest common factor that will put you in a question that looks like the first one. Do difference of two squares, which gives you nice two brackets that you can solve for x. Trinomials, which again could be two brackets where the first two terms gives us our first term and the last two terms gives us our last term. Or solving for x where we're using inequalities. So that's what we're going to do now. So next question. I hope you're ready. Let's write out the question and then just pause and give the question a try. So x bracket 3x plus 4 bracket minus 2 bracket 3x, let's go again, plus 4. Let's do less than or equal to 0, right? So in this question, you must remember that you can always simplify the one side. So you can definitely see, let me just bring it to light. We have our first term and we have our second term. And that's only because it's separated by a addition or subtraction. Between these brackets is a multiplication. You must remember, like the first example, a multiplication allows different numbers, brackets, numbers, variables to all become one family, to all become one, what we call term. All right. So this is where we are now. When we look at these two terms, can we simplify? So can we take out a highest common factor, do trinomials, dots, or grouping? So if we go back to it, there's our highest common factor. So we have bracket 3x plus 4, and what we left with is x minus 2. Okay, hope you're still with me. When we do inequalities, we must remember we have something called critical values. So that's what we're about to do now. Now we jump in and we just say critical values. So our critical values looks like we're solving for x. Now it just becomes 3x plus 4 equals 0, or x minus 2 equals 0, which is basically, obviously, maths lingo. You take the minus 2, move it over. It then goes from minus to positive. So equals plus 2. Same thing on this side. This was a positive, will now become a negative. This was a multiplication. It will now become a division. So then x equals minus 4 divided by 3. Okay, hope you're still with me. Then we draw this nicely on the number line. So on the number line, we then have minus 4 over 3 and 2. Understanding that this was, it's less than and equal to. Alright, so let's just write that out. It was less than, meaning negative, and equal to, meaning including. Okay, so that's why our circle is colored in, because this number is included. All right, so what we do then is we pick a variable in between these two numbers, or less than or greater than 2, to see for which variables does it make our initial statement true. So our initial question was up here. So let's put a 0 in and see where we are. So I'm putting a number in between negative 4 over 3 and 2. So if I put a 0 into there, I'm then left with a 0 there. That whole thing becomes a 0. So I've lost this whole number. Okay, so let me rewrite it for you so you can see it. So let's do it at the side. So if we have x bracket 3x plus 4 minus 2, 3x plus 4. If you add a 0 in front of the 3x, 0 plus 4 minus 2, 3, 0 plus 4. This 0 multiplies this whole thing, so that becomes nothing. This 0 also leaves that, so you're left with negative 2 times 4. Okay, that gives you then a negative 8. Right, so now you know in between here you have a negative, right? If you choose a number greater than 2, you can choose 4. So let's do it again. 4 bracket 3 times 4 plus 4 minus 2, 3 times 4 plus 4. Right, so you have 4 over 3 times 4 is? Okay, 3 times 4 is 12 plus 4 minus 2 bracket. 3 times 4 again is 12 plus 4. Okay, so then we have 4 times 12 plus 4, 16. Minus 2, 12 plus 4 is 16. 4 times 16 is 64. Minus 2 times 16. 2 times 16, 32. Okay, so we know 64, obviously minus 32 would be half of that, just 32. So we see that's a positive number. So we know this end is positive. And again, if we were to substitute a number less than, so like minus 2, let's redo it again. Just trying to go down. So if you go minus 2, so you must remember we're substituting from the original x bracket x 3x plus 4 bracket minus 2 bracket 3x. So we're using the original question to find where on our number line can we find a true value that makes the statement true, where the value is less than 0, meaning less than meaning negative. All right. So now we're substituting negative 2. So negative 2 bracket 3 times negative 2 plus 4 bracket minus 2 bracket 3 times negative 2 plus 4. Okay, so we have negative 2 bracket negative 3 times 2 is 6 plus 4 bracket minus 2. 3 times minus 2 is minus 6 plus 4. Minus 2 bracket negative 6 plus 4 would then be negative 2 bracket minus 2. Negative 6 plus 4 is negative 2 again. So negative times the negative there is positive 4. Negative times the negative is positive. 2 times 2 is 4. 4 plus 4 gives us 8. So our answer again is positive. So if we go back to our initial question, we see that our question wanted us to figure out where our values of x lie that are less than or that are negative. And we see that our answer lies in between these two variables, if that makes sense, right? So obviously this is how our parabola would kind of look like, but we know that our final answer only sits when any number that is greater than negative 4 but less than 2. So our final answer will look something like that, because our answer lies in between here somewhere. All right. Okay, so I just want to redraw that again. Yeah. Okay, so let's just redraw that again. I just wanted to show you, is this negative 4? So this is negative 4. And let me just redraw our parabola. Okay, just so you kind of have it. So another cheat or another simple way to always kind of work out any type of inequality. So again, our giveaway for our inequality will always be, you'll see it with either a less than. So this is an easy way when you type or write the word less. This L looks towards the E. So whenever we have a less than that looks something like that, that's an L, so it's less than. The other way would obviously be greater than. Then we could obviously have an equal to, which can be coupled with a less than and equal to, or a greater than and equal to. So you must always find, number one, first simplify. So simplify your equation to ensure that you're working with just one term. So if we go back to this initial equation, you can kind of see that in between my two brackets is a multiplication. So I was dealing with one term. So simplify until you have one term. Once you have one term, you're then going to find your critical values. So this is basically solving for x. Okay, once you've solved for x or found your critical values, you're going to put it on a number line. So the number line seems a little bit lengthy if you look at the work we did here. However, if you just find one answer, let's say one answer. If you just find, let me just rewrite, sorry. If you just find one answer, the other two are opposite. So if you have, for an example, in your number line, let's say it was not equal to, circles are 0, you have a certain number there A and a certain number there B. If you choose a random number in between C and C comes out to be positive, that means this will be negative and this will be negative. If you have another example, again, was not included a number A, any number, and a different number B, you choose a random number in between C. If that number comes out to be negative, then the two will then be positive and positive. And this is because whenever you draw a parabola, you will always have in the middle it to be negative, where the outskirts are positive. And if you drew it in the opposite function, same thing again. In the middle, it would be positive, and on the outskirts, it would be negative. So that's a quicker way, so you don't have to kind of work it out, but I did kind of work it out so you could follow along.